and atomicity. So recovery algorithms we are going to study. The first lecture already we have studied atomicity. So what is mean by atomicity? To maintain the database consistency, we need to ensure that all operation in the transaction need to be completed. All the operation of the transaction are need to be completed in all or not at all. Correct? That need to be complete. Otherwise, it results in data inconsistency or the database remains in inconsistent state. So one transaction we have seen already. 1 minute, it shows me your audio is not being recorded. Why? I will see that first and then start. Yeah, we will see later on. So here one example is given. Consider the transaction TI that transfer $50 from account A to account B. The example already we have seen so many times. So when we transfer this account 50 rupees from account A to account B, need to be complete all the operations. If after write a operation, if a failure occur, then in that case it results in data inconsistency. So whatever the state before prior to the execution of the transaction, it remains as it is after the execution of the transaction. So goal is either to perform all the database modification made by TI or none at all. None at all. So in this way, atomicity we consider. Now, if a failure occur, then how to recover? Even if we considering all these things, if a failure occur, how to ensure atomicity? So to ensure atomicity despite of failures, we first output all the information describing the modification logs to stable storage without modifying the database itself. So whenever we perform any modification means what? We change the data in A, we change the data in B or data item, we modify the value of the data item. So in that case, we say that we have done some modification. So whenever we done some modification or perform some modification, for each and every modification, the log is created. And these logs, see log and log, there is a difference. So many times in question paper, the question is asked about log or log. So read the word carefully. So such logs are created, and where these logs are stored? These logs are stored on the stable storage. So stable storage, we assume that never data loss on the stable storage. Why? Because in this remote storage concept is used. And that's why such modifications for which the logs are generated, and these all logs are stored on the stable storage. So there are two methods for this log, what we call it as a log based recovery. So there are major two types of recoveries, log based recovery and shadow paging. Log based recovery and shadow paging. So log based recovery mechanism has again two types, deferred database modification and immediate database modification. And less used alternative is the shadow paging. So if a question is asked any time for oral, what are the different recovery methods? So there are two main methods, log based recovery and shadow paging. Log based recovery again has two types, deferred database modification and immediate database modification. Now what is first, we are going to start with log based recovery. So as its name, see again I am telling that there is a difference between this lock based protocol, LOCK, lock based protocol, it is a concurrency control protocol, and log based recovery, it is a recovery method or recovery mechanism if a failure occurs. So log based recovery, the word log, what is this log? So log is the most widely used structure for recording the database modification. For each and every modification, database modification, a log is created. The log is a sequence of log records, not a single, multiple log records. It is a sequence of log records. Whatever the modifications we done in that particular transaction, For each and every modification, a log is generated. So it is a sequence of log records and maintains a record of update activities on the database. Whenever we update the database, update the value of a data item, a log is created. And all these together is generate a log records. Where the log is kept? Already I have told, a log is kept on the stable storage. It has the how to generate the log, or what are the values we stored in the log. So it includes the transaction identifier. It includes the transaction identifier. Then so for example, we are performing the transaction on the transaction is for TI. So transaction identifier TI, TJ, T1, T2, whatever. Data atom identifier XI means X1, X2, X3, A, B, C, D, P, Q, whatever the name of the data item. Old value we call normally it as a V1 and new value for V2. Means we transfer the $50 from account A to account B. So if it has a 200 and if it has a 100 as an old value, after transfer it becomes 150, it becomes 150. So it is V1 and it is V2. Is it clear to everyone? Yes or no? Next we are going to see how to write a log record for particular transaction. So simply log is a sequence of log records which store the information modification information or update information related to the transaction. So when a transaction TI starts, so what kind of log records are there? So when a transaction TI start, it register itself by writing TI start. It register itself by writing TI start log record. Before TI execute write X, a log record means if a transaction is performing some updates, then it creates a log record. When a transaction is perform a write operation, updates means write operation, then it create a log record TI X V1 V2. So what is TI? It is the transaction identifier, X is the data item identifier, V1 is the old value and V2 as the new value. V1 as the old value and V2 as the new value. Means in our case, suppose a transaction T1 transfer $50 from account A to account B. So what is the data item identifier? A. And what is the old value? 200. And what is the new value? 150. Now B added 50. So the data item B, old value 100, new value 150. So when a transaction T1 transfer $50 from account A to account B, these two log records are created. Along with TI start is created when it started transaction, T1 start is created. Is it clear to everyone? So when TI finishes its last statement, the log record TI commit is written. When the transaction completed all the updates, then a TI start log record, TI commit log record is created. We assume for that log records are written directly to the stable storage, means all these log records created are stored on the stable storage. So if a failure occurs, the data can be retrieved from these log records and then write operation is performed. Now here deferred database modification, or we are going to start with the first type of mechanism, deferred database modification. So deferred, what is the meaning of deferred? Anybody knows the meaning of deferred? Yes or no? Am I audible? So what is the meaning of deferred from dictionary? So the deferred database modification scheme ensures that atomicity by recording all modification to the log. Means as I told that logs are first created. Recording all the modification to the log means we transfer the 50 from account A to account B. So we need to modify the transaction, need to modify the data item A. Also the transaction need to modify the data item B. So by recording all modification to the log, all modification are first recorded, but differs. Defer means delay. Defer means delay, correct? Postponed or delay. So, but defer all write operation, actual write operation of the transaction until transaction partial commit. First, the log record are created for every modification. These are stored on the stable storage. But the write operation on the database, which is stored on the disk. The write operation on the database, which is stored on the disk, it is delayed or deferred until the transaction partial commit. When the transaction partial committed? When we say transaction is partial committed? Anybody remember? So when the transaction executes its last instruction, when the transaction executes its last instruction, we say it is partial committed. And once the transaction is partially committed, then only the write operation is performed. Means the information, whatever the value of A 150 and value of B 150, it is returned to the database which is stored on the disk. Only when the transaction partially committed after the last instruction. So in this case, see, I am asking a question. In this case, if a failure occurs anywhere, is it required the old value or both values are required, old and new? Anyone? See, listen again the question first. In deferred database modification, the logs are first created for each and every modification, and these logs are stored on the stable storage. And defers the write operation, delay the write operation until the transaction partially committed. Once the transaction partially committed, then the values which are updated by the database for that data item are returned to the database on the disk. So in this case, the old values are not required. So in this case, old values are not required. Why? Because in between, if a failure occurs, then new values are not returned to the disk. New values are not yet returned to the disk. So old values are not required. Because the database remains as it is in the state. Old value remains as it is. Why? Because the write operation is not performed until partial committed. And that's why in this case of deferred database modification, only new value is required. Only new value is required. Now see it with example, then it will be clear more to you. Okay, so assume that transaction executes serially. Transaction start by writing TI start, then write X operation result in a log record TI, X and V. So what is this V? It is new value. As I told you that old value is not required. So old value is not needed in this scheme. Why? Because the transaction perform all the write operation after it is partially committed, and that's why the old value is not required, only new value is required to be stored on the log. Now see, the write is performed on the X at that time but is deferred, not performed at that time, it is deferred or delayed when TI partially committed. When all the instructions of TI are executed, then TI commit is returned to the log, and then finally log records are read and used to actually executed the previous deferred writes. If a failure occurred, that part we are going to see with example. Now see again in short, remember that in deferred database modification, how we assure atomicity? By keeping all the modifications on the log, and these are stored on the stable storage. But the write operation on the database, it is deferred or delayed until the transaction partially committed. Assume here we consider that first transaction executes serially, sorry, and here only new value is required, old value is not required. Now see the next with example we will see. Okay, so during the recovery after a crash, the transaction needs to be redone if and only if both TI start and TI commit is there. If TI start and TI commit both are there, means all the instructions of the transactions are executed. Then it need to be redo. What is mean by redo? Set the value of all data items updated by the transaction to the new values. Set the value of all data items updated by the transaction to the new value in case when we got both TI start and TI commit. Only if there is a TI start, no TI commit, then not necessary to do anything. If there is only TI start and no TI commit, then not necessary to do anything. Why? Because no updates are done on the database. Database is already in the prior state. Not necessary to do anything. But if both are there, means updates are made to the database. So in that case, set the value of all data items updated by the transaction to the new value. Now see how to write the log record for these two transactions. We are going to see it first. So T0 read A. First T0 started. So first log record which is generated is T0 start. Okay. For read, not necessary to generate a log record. Log is created only for the modification, means for only write operation. Okay. So here it performed the write. Here we consider that initially A is equal to 200, B is equal to 100. Now, it performed the write operation, means we need to write a log record for it. So T0, on which data item it is performing? A. It perform a write operation on A. And here in this deferred database modification, we need only the new value. What is new value? 150. Now read B, not necessary to write a log record. Then add 50 into B. So here we need to write a log record T0 on data item B and the new value 150. Now transaction is partially committed. Okay, all the instructions are executed. Then once the transaction is partially committed, T0 commit. And then the values 150, 150 are returned to the disk. So if a failure occur before this, not necessary to do anything. If a failure occur before this, not necessary to do anything. Why? Because values are returned to the disk after the transaction is partially committed. Now for this we are going to write a log record. First T1 start. Here we consider C is equal to 700 initially. C is equal to, for read, not necessary to write a log record. Write C, we need to write a log record. T1, C, old value 700, so new value 600. And then once it is completed, then T1 commit. So in this way, the log records are written. Where it is written? These log records are stored always on stable storage. These log records are always stored on stable storage. Okay, so that is shown here. Am I audible to everyone? Yes or no? Only 66, 67 students are there today. Am I audible, Priyanka, Vaishnavi? Okay. So in this way, the log records are created. You can see here T0 start, T0A. Here values are different. 1000 and 2000 are taken for A and B. So once A becomes 950 as a new value, B becomes 2050 as a new value, then C as a 600. So here A initially consider 1000 and B 2000. Now see how the deferred database modification actually execute. So that is shown here. First it create the log record here. First log record T0 start. Then it create a log record for write operation of A with the new value. Then it create a log record for data item B with the new value 2050. And then once all these operations are executed, it write a log record T0 commit. Means the transaction T0 partially completed or committed. Then the values of A and B are stored on the disk in the database or returned to the disk on the database. Is it clear? In the same way, T1 start, T1 C, it write a log record for write operation of C. T1 commit, once it is committed means partially completed, then the value of C, it is returned to the database on the disk. Is it clear to everyone? It's a simple concept. Yes or no? Okay. Now, if a failure occur, then how it work? If a failure occur, how it work? So, see, here three examples are given for the same transaction, two transaction. Suppose the failure occurs here. What happens here? T0 start means transaction T0 started. Then the value log record for A is created, log record for B is created. But where T0 commit is there? So before T0 commit, if a failure occur, then whether we need to do redo operation. What is redo operation? It set to the new values. It set all the data items to the new values. So is it necessary to do the redo operation here? Yes or no? Is it necessary to do the redo operation here? Yes or no? No, not necessary. Why? Because here T0 start is there, but T0 commit is not there. T0 commit is not there. So, correct. T0 start is only there, not necessary to do anything. Not necessary to do anything. Why? Because the transaction is not committed. That's why values are not returned to the disk, which is on the database. So, what are the values of A and B here? In this case, what are the values of A and B on the disk? If a failure occur before commit, these are as it is 1000 and 2000. These are remains as it is 1000 and 2000. Now we consider the second. Suppose a failure occurs here. If a failure occurs here. So in that case, what we need to do? We check. T0 start is there, T0 commit is there. Means the transaction T0 already partially committed. The values of A and B already returned to the disk. Correct? So in that case, we need to redo T0. What is meant by redo T0? Set the value of all data items to the new value. So what is the value of A here in this case now? 950. And what is the value of B? 2050. Now what about the transaction T1? Here we can say T1 start, but no T1 commit. Means the transaction T1 is not yet partially committed. Before committed, the failure occurs, so not necessary to do anything regarding C. C remains as it is 700. C remains as it is 700. So in this case, here if a failure occur, A is set to the new value, B is set to the new value because T0 start and T0 commit both are there. But T1 commit is not there, so C is equal to 700. Now we can see the next. If a failure occurs after this, if a failure occurs after this. So T0 start is there, T0 commit is there, so we need to do redo T0. So what is the value of A? It is set to the new value 950. B is equal to 2050, and here T1 start is there, T1 commit is there. So it also here we need to do redo T1, and C becomes the new value 600. So if a failure occurs after this, we need to redo both T0 and T1. We need to redo both T0 and T1. So is it clear? So that we can start with the next part. Yes or no? Okay. So immediate database modification. So as its name, immediate means in this scheme allow the database modification to be output to the database while transaction still in active state. Uncommitted modification. What we call it as a uncommitted modification means before transaction partially committed, the all operations or whatever the modification are output to the database. Means write operation to the database on the disk is performed immediately. That we call it as a immediate database modification. So in this case, what we required, old value only, new only sufficient. New value only sufficient? No. In this case, along with the new value, we require the old value also. We require the old value. So since undoing may be needed, update log must both old and new value. Both old and new values are required. So see again the same example we are going to see here. So here transaction A transfer $50 from account A to account B. So here along with the new value, old value is also required. Along with the new value, old value is also required. All other things are same. Start the transaction, commit the transaction, whenever perform the modification on any data item, it create a log. But in log, along with new value, old value is also required. Means here as the old value is also required. See why it is required. What happens here? You can observe here. Before the transaction committed, the values are written to the database on the disk. Anywhere, it may be written here also directly. After performing the modification of A, value of A is written to the database on the disk. After the modification of B, B is written to the database on the disk. After the modification of C, C is written to the database on the disk. Means before the transaction is committed, partial committed, before all the instructions of the transaction are executed, the values are written to the database on the disk. So if a failure occurs before this, we require the old values. If a failure occurs after this, then we require the new values. Is it clear? If a failure occurs in between this, then we require the old values. And if a failure occurs after this, then we require new values. So simple concept is here that whenever a failure occurs, if both TI start and TI commit, if both log records are there, means the transaction is partially committed, and after that if failure occurs, then we require to do redo. What is redo perform? It restore to the new value or store to the new values. But if before TI commit, only TI start is there, no TI commit is there, means transaction not yet committed, and if a failure occurs, then in that case we require the old values, and for that we need to undo it. Undo it means here in the immediate database modification, two operations are required, undo and redo. Now see it. Okay. So recovery procedure has two operations instead of one. That already I told you. Undo TI. Restore the value of all data items updated by TI to their old values. Restore the value of all data items updated by TI to the old value, and redo TI set the value of all data items updated TI to the new value. So simple, if a transaction TI has TI start but does not contain TI commit and failure occurs, then we see there is a only TI start but no TI commit, need to be undone. The transaction need to be undone. And if any transaction has both TI start and TI commit, in the case of failure, then TI needs to be redone. Means here we require old values and here we require new values. Is it clear? Now see it with example. The same example. So first we consider the first case in which if a failure occurs here. If a failure occurs here, then we require redo T0 or undo T0. I need your response now. What we need to do? Redo T0 or undo T0? Yes, we need to do here undo T0. Why? Because the transaction not yet committed. Only T0 start is there. So what are the values of A and B here? These are restored to the old values, that is 1000 and 2000. Restored to the old values, that is 1000 and 2000. Now in this case, if a failure occurs here, T0 start, T0 commit means we need to do redo T0. Need to do redo T0. So A is stored to the new value 950 and B is stored to the new value 250. But T1 start is there, no T1 commit. So here we require undo T1. And C is equal to old value 700 as it is. So have you understood why we require both old and new values? In the immediate, why? Because it is an immediate modification. And in this case, if a failure occurs here, both T0 start and T0 commit is there, means we need to do redo T0. A becomes 950 new value, B is equal to T050, and also T1 start and T1 commit is there, so we need to do redo T1. C is equal to new value 600.